Okay, this video is to go over section 5.1.1, the undo equations section. So problem 5-2, a picture of Anita's function machine is shown at right. When she puts a 3 into the machine, 7 comes out. When she puts a 4 in, 9 comes out. And when she puts a -3 in, -5 comes out. Make a table to organize the inputs and outputs and explain in words what's happening. So, inputs are X, outputs are Y. She puts a 3 in, she gets 7. She puts a 4 in, she gets 9. She puts a -3 in, she gets a -5. Explain in words what's happening. Okay, so how can I go from 3 to 7? Times 2 plus 1, does that work? 4 times 2 plus 1 is 9. -3 times 2 plus 1 is -5. So definitely it is multiplying by 2, then add 1 in words. That's what it wanted. So there is A. B, Anita's function machine suddenly starts working backwards. It begins pulling outputs back up into the machine and reversing the machine's process and returning the original input. If 7 is put back into the machine, pulled back into the machine, what value do you think will come out of the top? Well, 7, oops, I was supposed to change colors there. 7 comes out if you put a 3 in. So if it's going backwards, B, you must get a 3. C, Anita sets up her new backwards function machine and enters the other outputs. What would you expect to come out at the top if 9 is entered? So look at what we've done so far. What do you expect to come out if 9 goes back into the backwards machine? Well, backwards up the table from 9, it must be 4. Then -5. If you put -5 in, it must give you -3. Record the inputs and outputs of the backward function machine in a table. Record the numbers being pulled back in as X and the numbers coming out as Y. Okay, so a new XY. Now when you put 7 in, a 3 comes out. When you put 9 in, a 4 comes out. When you put -3 in, a -5 comes out. So we need to come up with, in words, what's happening. So how do I go from 7 to 3? Well, I have to divide by 2. How about subtract 1 first? Sorry. I have to subtract 1 with a C. Then divide by 2. 9 minus 1 is 8, then divided by 2 gives me 4. So this definitely does it. So write an equation for her original and her backwards. So her original, if it's y equals, you take a number, x, and you multiply it by 2 and then add 1. There's the original equation. For her backwards equation, y equals, you take a number, x, and you subtract 1, and then you divide that answer by 2. How are the two functions related? Well, they undo each other. They're backwards. They undo each other. Okay, let's see what's next. The function machine at right uses the function f of x equals 5x plus 2. If the crank is turned backwards, what number should be pulled up into the machine to have 4 come out the top? So I have, you can use y equals, but f of x is fine. 5x plus 2. When I do that, what number should be pulled up into the machine to have 4 come out the top? Well, just like this picture shows, if I plug 4 in, 5 times 4 is 20, plus 2 is 22. So if I want 4 to come out the top, 22 needs to be pulled back up the machine so that I get 4 coming out the top. Keiko wants to build a new machine that will undo what f of x does to an input. What must his machine do to 17 to undo f of x and return a value of 3? So if we're taking the equation and we're undoing it, it needs to subtract 2 and then it needs to divide by 5. Right? Because if I do 17 minus 2, I get 15. Divided by 5 gives me 3 coming out the top. An undo function is called an inverse function. It has the notation of f to the negative 1 of x. Notice that the negative 1 is not a negative exponent. It's the mathematical symbol that indicates inverse. Write a function for f inverse of x to undo the machine. So I'll stick with green. To undo f inverse of x, it needs to take your number and subtract 2 from it, and then divide the whole thing by 5. Choose a value of x. What strategy can you use to show your equation f inverse of x undoes the effects of the original? Explain. Well, my original is over here. So what if we plug in x equals 2? If I plug in x equals 2, 5 times 2 plus 2, y should equal 12. Well, let's test it over here. If x equals 12, I'm plugging in 12, not x. 12 minus 2 divided by 5, 10 divided by 5, I get 2, which is what I started with. So it's definitely undoing the original function. Okay, Keiko is working with a new function, g of x. She writes down the following steps for g of x. It's going to add 5, then divide by 2, then cube it, then multiply by 6. What is the equation for g of x? G of x equals, you start with a number x. You always have to start with a number. I'm just going to do what it says. Add 5, divide that whole answer by 2, cube that whole answer, and then multiply it by 6. We can put that in front, right? 6 times that. What is the output when the input is 3? So plug in 3. 6 times 3 plus 5 over 2 cubed. So 6 times 8 over 2 is 4 cubed. 4 cubed is 64. Times 6 equals 384. When you plug in 3, you get 384. Okay, help Keiko write down the steps in words for the inverse of the machine. Okay, so up here, the inverse is when you go backwards and you do the opposite thing. So instead of multiplying by 6, I'm going to divide by 6. Instead of cubing it, I'm going to cube root. Instead of dividing by 2, I'm going to multiply by 2. And then instead of adding 5, I'm going to subtract 5. So I went backwards, and I did the opposite thing. So to come up with the equation, g inverse, I'm just going to do what it says in red, in the order it's written, because I already did it backwards. I'm going to take an x, and I'm going to divide it by 6. Then I'm going to cube root that. Then I'm going to multiply that whole answer times 2. I'm going to move this. Multiply that whole answer times 2. And then I'm going to subtract 5. This is what g inverse of x equals. Verify that your equation to part B is correct. Well, I already know when I plug in 3, I get 384. So let's plug in 384. Into our inverse function. So 384 divided by 6 is 64. The cube root of 64 is 4. 8 minus 5 is 3, which is what I was supposed to get. So they are definitely inverses of each other. Okay, what are the inverses and justify? So A, let's do A here. It says 3x minus 6. So it would multiply by 3. Then it would subtract 6. So if I'm doing the inverse, I need to go the opposite order and the opposite thing. So add 6, divide by 3. So that function was called f, so I'm going to write it as f inverse of x is going to be x plus 6 all over 3. And then right now, if I want to prove that, let's just go with x equals 2, right? So f of x when x equals 2. I get 3 times 2 minus 6. It happens to be 0. But now if I do f inverse, when x equals 0, 0 plus 6 divided by 3, and I get my 2 back out. So I get the original number that I plugged in. I'm not going to do that for every single one of these. I want you guys to check that on your own, but let's keep finding the inverses. So let's do B. Right now, it cubes a number, and then it subtracts 5. So if I'm going to do the opposite order, opposite function, I'm going to add 5 and then cube root. So G, because that one was called G, so G inverse is going to be x plus 5, and then I cube root all of it because it's the last thing I do. Why don't you see if you can find C and D? I'm not going to show all my work for those. See if you can find the inverse equations for C and D. Pause your video. Okay, there are my answers for C and D. If you got them right, then you're good. If not, I will go over it real quick. Maybe I'll just go over C. So for C, what's happening in the original equation is it's taking x, it's adding 3, then it's cubing, then it's multiplying by 2. Oops. So I need to go opposite order, opposite function, because I'm undoing it. I need to divide by 2. I need to cube root, and then I need to subtract 3. And that's where all these numbers came from. Hopefully this is a good intro to inverse functions.